Rottguard Fire is a globally recognised manufacturer of fire suppression systems and supplier of products and services that protect people and critical assets from the dangers of fire. The Direct Acting Low Pressure DLP Rottguard Fixed Fire Suppression System is cost-effective and manufactured at its facility in ISO 9001-2015 for the protection of electrical enclosures, server cabinets and fume cupboards. Rottguard DLP systems have been tested to LPCB LPS 1666 for use in protecting defined spaces and by Exover Warrington Fire on Class A, B and electrical test fires in accordance with NFPA, AS, ISO and ISEN standards. The system is CE marked and complies with 9723 EC Pressure Equipment Directive. DLP systems use HFC 227EA, a clean, non-conductive, colourless and environmentally friendly fire suppression agent that leaves no residue and is safe for humans. It extinguishes flames primarily through heat absorption. Join the live Q&A to ask your questions directly.
I'm Gerard Lenihan, Managing Director of Rottguard Fire Systems. Today I'm going to introduce you to a range of 6 different fire suppression systems for local applications, and I will go through each one with you individually. I'll start with this system here, designed for the protection of commercial kitchens. It uses a wet chemical agent. These are our nozzles. We have a range of 6 different nozzles. Each one has been designed to achieve a specific discharge angles and flow rates. They have stainless steel blow-off caps, which are preferable to the rubber ones. We can have a manual release. The temperature is sensed by these thermo bulbs. They're German made and UL listed. They also come in 6 different temperature ranges. And the whole system was designed with the installer in mind to be able to quickly install it using a template here to cut out the holes for the discharge pipes here into the side of the stainless steel canopy. The system can be interfaced to control the gas shut-off valve. It can also be used to control the electrical supply to the cooking appliances and also to interface with any existing fire alarm systems. It can also be discharged manually by lifting this sealable flap here and operating the button here. These have the advantage in that they don't have to be replaced. They're a lifetime use and only need to be replaced if one of them bursts. They come in 2 different forms, with a steel cylinder like this painted, and we can supply them with a stainless steel cylinder. We can also supply them in a stainless steel enclosure. This here is a clean agent direct low pressure system. It can be used with either HFC 227EA or FK5112. It's like our DLP system in that the tubing here, once it's exposed to the heat of a flame at 80 degrees C, it will rupture and discharge the contents of the cylinder down on top of the flame. In instances where the working temperature of what's being protected exceeds 80 degrees C, We use these thermal bulbs that are built into nozzles. Essentially, these nozzles, they atomize FK5112 agent, and again, these are a German-made UL listed thermal bulb. They come in different temperature ranges. In the normal course here, the tube here will rupture on exposure to the heat of a flame at 80 degrees C. In instances where we're trying to protect an enclosure where the operating temperature exceeds 80 degrees C, we use these combined thermal bulbs and nozzles. The thermal bulbs come in 6 different temperature settings. The design of the system is such that we normally choose a thermal bulb that is 30 degrees C above the normal operating temperature of the machine or whatever else the enclosure that we're trying to protect. These systems are essentially maintenance free. They can be interfaced with a fire alarm system, or we are introducing a GSM control unit whereby if this thing discharges or there's low pressure, that it will send a signal to someone's phone in the form of a text message, and it can be monitored in that way. They're easily installed. We've had a system certified by SGS UK for compliance with the pressure equipment directives. The system has been tested by Exova and also by BRE Global to the LPS 166 standard. This here is our high pressure CO2 indirect application system. We use it for the protection of machinery like this. CO2 is the only agent that is recognized within the NFPA standards for local applications that are not totally enclosed. It's very effective compared to the clean agents in that it knocks down fire very quickly. CO2 is stored here within the high pressure cylinder. The control side of the valve is low pressure, and we can monitor the pressure on that side through a pressure gauge here, and we can also interface with a GSM unit or a fire alarm system, or we can control the shutdown of an engine through a pressure switch like that, or a series of pressure switches if necessary. As with these distribution blocks, we can fit pressure switches at different locations along the way. We designed this system with the installer in mind, and also taken into consideration the difficulty that can arise in protecting such machines. By installing these distribution blocks, it ensures that the system can be quickly installed and is secure after. They are relatively maintenance free. There is a requirement to pressure test the cylinders every 10 years, but they can be reused again, and it's quite easily to get the CO2 refilled in instances where you have a fire and system discharges. Sometimes you could use a combination of systems to protect something like this. It knocks fire down quickly and it leaves no residue, which is important. Again, these are low maintenance systems, and if they discharge, it's easy to get the CO2 cylinders refilled in most parts of the world quite easily. This is our direct low pressure application system. It uses a clean agent. We can use FM200 or Novec 1230, which are their common brand names. It uses a pressurized tube here and will rupture when the temperature here reaches 80 degrees C. The system is maintenance free. We can monitor for low pressure or in the event of a discharge through a second pressure switch, which will interface with a fire alarm system or a GSM monitoring system. In this instance here, it will only necessitate the replacement of this contactor, which minimizes the downtime apart from the cost. These systems we've installed in many industrial applications here in Ireland, and they've been exported to over 20 countries across 5 continents. The system was inspected and certified by SGS UK for compliance with the pressure equipment directives, by Exova for different aspects of the clean agent standards, using 3 internationally recognized fire test conditions. It was also tested by BRE Global for compliance with their LPS 166 standard for such systems for the protection of small, defined, unoccupiable enclosures. This is our pre-engineered low-pressure dry chemical system. It is ideal for the protection of machinery, as distinct from the other agents. You can use it as a combination of the two if necessary. This is our pressure differential valve. It operates on the principle that the nitrogen pressure here within the tube will keep the valve closed, and once the tube is exposed to the heat of a flame at 80 degrees C, it will cause the valve to open. In instances where the environment being protected, the space, the enclosure exceeds 80 degrees C, we can supplement it with these German-made UL listed thermobulb. They come in different temperature ranges, and we normally design the system so that the one chosen is 30 degrees above the normal working temperature within the machine or the enclosure being protected. Being a pre-engineered system, we determine the length of the hoses up to the distribution block, and after that the branch lines out to the nozzles. The nozzles have protective blow-off caps. They're German made, they're UL listed, and they come in 6 different temperature ratings. They're low maintenance, and we can use the pressure switch or pressure switches to interface with the control of the engine on the machine, to interface with a fire alarm system or a GSM monitoring unit that will send a text message to the customer to the effect that the system has discharged, that the pressure might be low, and if we use thermocouples in association with the GSM unit, we can also monitor a pre-warning situation whereby the customer can see a rising temperature within the protected area, but the GSM unit does not control the system. The system is reliant on the pressure being contained here within the tube. We use ultrasonic leak detectors to test the system once it's installed, and after that they're generally almost maintenance free, apart from the requirement to inspect the powder in the cylinder on an ongoing basis. This is our indirect application clean agent system. We can use one of 2 agents. We can use FM200 or Novec 1230. If we use FM200, we use this corkscrew shaped nozzle to discharge what is a liquefied gas here. If we're using Novec 1230, which is stored as liquid, it atomizes when it's discharged out through these nozzles. We're using hoses here as a means of discharging the agent. They give us a flexibility in trying to install the system, oft times in very confined spaces. The distribution blocks provide a means of securing all the various components. If we have a fleet of buses, we can interface these systems through a pressure switch. The pressure switch will signal to a GSM unit to the effect that the system has discharged, that there's low pressure in the cylinder, or indeed if we use thermocouples in conjunction with the GSM unit, that we can monitor it for a pre-alarm situation whereby the driver of the bus is alerted to the fact that there's an increase in temperature inside the engine, and in that way alert him prior to there being a fire in the engine bay. In instances where the fleet of buses are parked up, these GSM units, they can be programmed for individual vehicles, and so the customer will be able to monitor the system remotely. The systems in themselves are virtually maintenance free. They rely here on the tube to rupture at 80 degrees C on exposure to flame. In instances where the working temperature of the system exceeds 80 degrees, we're using these German manufactured dual listed thermal bulbs. These are set at any one of 6 different temperature settings, and we designed the system so that they operate at a temperature 30 degrees above the normal working temperature of the vehicle that is being protected. The valve, even though it is similar to the CO2 valve, is designed to operate at 25 bar. It has a different rupturing disc inside in it, and also the pressure regulated for the low pressure side of the valve differs to the one used for CO2.
Hello to you all, I'm Jo Pickard, and a big thank you to Rottguard and of course Jared Linian for a fantastic FIREX Tech Talk. Thanks to all of you for joining us. I really hope that you're enjoying all the talks. I know I am. So we have people joining the talk right now for our live Q&A. So to make sure you pop your questions through the Q&A tab on the right hand side of your screen, you'll also be able to see other people's questions, and if there's one that you're interested in hearing the answer to, make sure that you upvote it, and so that I know it's a popular question, and I'll make sure that Jared answers it. Now, I'm really pleased to have a live Q&A here, and thank you so much for joining us. How are you doing over there in Cork?
I'm very good, thanks, Jo. Yeah, I'm very good, thanks.
Oh, brilliant. Now, so would it be possible for you to be able to, there's some people that have maybe joined the Q&A that haven't watched the video just yet. So could you maybe give us maybe a potted version, an overview of the products and the benefit?
Okay, we have been producing direct application fire suppression systems specifically for the protection of electrical cabinets for some years. We took this opportunity to launch our indirect application systems, which have the capacity to protect larger volume areas with different fire risks than the direct application one. On the panels behind me, you can see an array of these systems. They use different agents, from clean agents. They use wet chemicals for the protection of commercial kitchens. We have one there that uses CO2, and there's a dry powder one. And then there's another system there that can use one of 2 clean agent systems for the protection of buses. But when we have an array of images Sometimes you can use a combination of such systems to protect different risks. Um, not one agent is a catch-all for every fire risk at the end of the day. And that is why we're introducing these systems at this stage. And we hope to have them all certified before the end of the year, at which time they will be launched onto the market. But as it is, we supply and install a lot of our direct application systems.
Have you had any response from the market as like, I know they're not on the market yet, but have you had any response from people so far? Any surprising reactions?
To the introduction of the systems, is
Exactly.
it?
Yeah.
Yeah, we've had a lot of requests for such systems over time, but there's a lot of work and effort in developing them, having them tested in-house, and we had to go through all that process before we got to the point where we could essentially launch them here today. And this seems like a good opportunity for us to do so. In the making of the video, we were conscious of the fact that we had to go into all details of the various systems. But I have since discussed it with the video maker, and our intention is to hone it all down to a much shorter version and put it on the homepage of our website. And in that way, somebody will be able to go in and get a good insight into what it is we do, the capacity of these systems, and if they need more information, there will be separate videos on each and brochures on each different system.
Well, that's a really good idea. Video is king, so you're doing the right thing. How do the DLP fixed fire suppression systems operate?
How do they operate? There's one of two clean agents stored in the cylinders. It's pressurized with nitrogen. There's a tube attached to it, and the tube is installed throughout the electrical cabinets or server cabinets. They can also be used to protect fume cupboards. And when this tube is exposed to the heat of a flame at 80 degrees C, it will burst and creating a nozzle effectively anywhere along the length of the tube and discharge the agent directly down onto the fire. One of the images there in the video shows an image of a switchgear inside an electrical cabinet, and it shows a contactor on fire there. And these DLP systems are ideally suited for that because they will catch that fire in its infancy and extinguish it and minimize any damage, and with the result that one would only have to potentially replace the component that has gone on fire. And in catching and extinguishing the fire at that point, it prevents the fire developing into something bigger that otherwise might get out of hand.
Well, let's face it, that's what we're all aiming for, isn't it? And
Yeah.
also much more cost effective for the customer as well. Um,
Yes.
so, what extinguishing agents are used in the DLP suppression systems and why?
Why? Well, we use HFC 227EA, commonly known by its trade name of FM200, or we use FK5112, commonly known as Novec 1230. Um, the first one is a liquefied gas. The second one is a liquid in itself, and it vaporizes into small particles when it's discharged through the tube. These agents are the most commonly used agents throughout the world for energized electrical equipment, computers, servo cabinets, and obviously electrical cabinets. And because it's a clean agent, it leaves no residue, which is important as well. And there's no cleanup. And at the design concentrations, it's harmless if some of it leaks from the protected cabinets into the room in which the cabinets are located in a switch room, for example. CO2, there's another panel there in our video which shows the use of CO2 protecting a different application, and CO2, while it's faster acting, is an oxygen depleting agent. So one has to be careful in the manner and the locations in which that is used. And as well as that, the FM200 and Novec 1230, they can be stored at low pressure, whereas an agent like CO2 is stored at a higher pressure, and something like dry chemical, while it can be stored at a low pressure, it can be corrosive when it discharges. It's messy and it needs to be cleaned up. If you were to use it to protect an electrical cabinet, for example, it could do as much damage as a fire itself. While it's very effective at extinguishing fire, it is not an agent I would recommend for the protection of electrical cabinets.
But I suppose if a customer's coming to you to be able to help them with a problem, you're going to give them all of the information that they need for that specific product that they're going to use, and where to put it and how to store it. So there's no fear from any of the customers from that perspective, is there?
No, there's not. Every time we get an inquiry, we have to submit all the information on what it is we propose installing them. Each time we get an inquiry, I generally ask for a copy of a CAD drawing of the electrical cabinets. I can superimpose a design down on top of those drawings. I factor in any louvered vents in the cabinet, so that I can make allowances for the rate at which the gas is likely to leak in the cabinets, and design the systems accordingly to compensate for such leakage. And I make all this information available to the customers. Sometimes I'm asked to go on site and explain all this to the customers, because in many instances over the years, my experience is that when people hear the term fire suppression system, it's like they instinctively associate it with CO2, and they all think they're going to suffocate if the thing discharges. So you have to reassure them that what we're proposing and what we offer is going to do the job and is not going to affect any personnel in the area. And once you explain all that to them and show them the videos of the way in which the system was tested, at that point they'll often go away and submit the details, the proposal, the design to their insurers, and then they come back maybe a week later and you get a purchase order off of them, which is what it's all about,
I'm sure if anybody can reassure them, it's you. So
yeah,
you mentioned stainless steel blow-off caps are preferable to rubber alternatives for the kitchen system. Why is that?
Because the rubber blow-off caps, they're very flexible. They have to be to blow off. If they were too hard, they wouldn't blow off. The problem with them is that oftentimes the suction created by the extraction fan within what's called the plenum above the filters in the kitchen canopies will blow these off. Some of the chefs in the kitchen, they move around a lot. They're concentrating on what they're cooking, and they can accidentally knock off these rubber blow-off caps. Mm-hmm. And when that happens, the atmosphere in the kitchen is such that oftentimes the air is laden with grease from the cooking process, and that will rise up and block the orifices in the type of nozzles used for wet chemical and the protection of kitchens. and the rubber blow-off cap, which is commonly used in a variety of these systems, is designed to prevent that. But my experience is that if they blow off, sometimes they tear. People don't realize the significance of it. And then if there's a fire, the nozzles, the orifice in the nozzle is blocked, and the liquid agent is incapable of being discharged. And so for that reason, the stainless steel one, it's held in place on our nozzles with a piece of stainless steel wire. They're neat and tidy, and they're held in place by a rubber O-ring, and they have gone through extensive testing for the pressure at which the agent is discharged to ensure that in all instances it will always blow off. As well as that, cleaning is a big thing in these commercial kitchens. They like to keep everything nice and clean and shiny.
To do. Well, thank you so much for your time, Jared, and thank you very much to Rottguard as well. This is the end of our Q&A. It's gone so quickly. Thank you very much. Now, our final talk is coming up at 11:30 in like 2 minutes with Ken Tech. So get yourself on there, and don't forget the registration will be opening soon for the next Tech Talks, which are on the 26th and 27th of April. See you soon.
Great. Thanks very much. Thank you. Bye now. Bye.